Hey, I'm Michiel Westerbeek and I'm the co-founder of Tella. And before Tella, I built a startup uh, called Copy, which we sold to Envision. While working at Envision, we saw people making videos about their work and sharing them on Slack. These videos contain slides, screen and camera recordings, and fun annotations like GIFs and stickers. And multiple teams worked on these videos together by recording their own parts and then sending them to the person finalizing the video in video editing software. We saw that the more work people put into these videos, the more responses and likes they got on Slack. These videos helped teams across different parts of the organization stay up to date with product development and other changes inside of the company. Unfortunately, making these videos can take a long time, and you need some experience with video editing software to make them really nice. We we asked some team members how long they spent on some of their videos, which were usually around 5 minutes max, and some would spend half a day on making them. Also, working together on these videos can be a very slow process. You need to export and send these videos to your collaborators while you're working on them. These were all reasons why we decided to build a collaborative video editor in the browser with a real-time editing and a sharing without an export or publish step. A user should be able to record, edit, and work together on a video and instantly share it with their viewers without slow processes in between. To make this possible, we built our own video player which plays back multiple video elements as if it's one video. To make it more clear how Tella is used, I'm going to show you a very quick demo, and after that I'll go more into the technical details.
So here we are in the Tella editor, and we've got a video that we're working on. You can see that we've got a camera recording there and some text on screen. Now, if we wanted to modify this, we could go ahead and add other video content like recordings or uploads. We can add GIFs, stickers, images, shapes, text, and even call to action buttons. On the canvas, you can select any layer, move that around so that you can design the layout the way you want. And then we can open up the timeline to fine-tune our video a bit more. When we open up the timeline, you can see that our video is split into two scenes. We've got a scene for this week's update, and then we've got a scene for next week's update. Within each scene, you can just modify the timeline as you would with any kind of regular video editor. So we can trim and split our layers. So let's say we want to bring this text layer in a little bit later. We can just trim off the start there. And now when we play that back, you can see that that'll come in a little bit later. So if we wanted to make this a little bit more interesting, let's go ahead and add a sticker, maybe like a wave. And there we go. So we've added that wave there. We can put that in the right spot on the canvas. That's pretty good. But that's not exactly what we want on the timeline. So let's go ahead and put that at the start and trim off some of this so that it aligns with the text layer. So now when we play that back again, it looks the way we want to. The next cool thing about Tella is that it's completely collaborative. So if I wanted to invite my co-founder Michiel to record his update for next week's plan, I could just send him the link and then he can go ahead and do that. So let's take a look at how that works. Here we can see Michiel jumping into that scene, and now he's changing the text to Michiel's update. He's also renaming the scene, so that's clear. And now he's going ahead and recording his own message for the update. So he's replaced that video that was in there originally. He gets a countdown, and now he can go ahead and say his update. So finally, Everything in Tella happens in real time. So once you've shared a video with your viewers or you've embedded it on your blog or website, if you need to update it, you can do that whenever you like. So we've got our video here in view mode. And if we pause that and jump back into edit mode, we can go and say, move this title over here. That's not exactly the prettiest spot, but if we jump back into view mode, you can see it's already happened there. We don't need to change the link or reshare it. All these changes happen in real time. So this saves you having to worry about getting everything exactly perfect or needing to re-export or redistribute if you've made a mistake and need to fix it. You can do it whenever you like.
Now, let's go more into the technical details. We'll start with recording. Tella allows you to record yourself inside of the browser with the Media Devices APIs, specifically with a Get User Media and Get a Display Media. These APIs give the developer access to streams of your camera devices and screens on your computer. A Get User Media has been around in most browsers since 2015, and it's used often for things like a meeting or streaming apps. A Get Display Media came a bit later, around 2018, and still has quite some inconsistencies across browsers. For example, in Safari, you can't pick a window or tab, but only record the full screen. In Firefox, you have to pick your window from a drop-down, and most browsers also have low frames per second when recording a screen. The way to record these streams is by using the Media Recorder API. This is a more recent API, and it's still not enabled by default in the latest Safari. Once you've made a recording, you can upload the resulting file to your backend and convert it to the appropriate formats. We record the camera and screen as a separate file, so we can rearrange them later on if we want to. After a video is recorded, we use the local file first until the video is uploaded and converted. After that, each video has its own HLS stream that we use for playback. We also listen to events from the video elements to know if it's playable or if it's still loading. When all video elements report that they are playable at a specific time, we can play them on our timeline. This timeline defines the structure of the video and what will be displayed on the screen at a specific time. To orchestrate all the different elements appearing at the right time, we use a high-resolution timer. JavaScript has things like a set timeout that can call functions after a time period, but these are not accurate enough to use for video playback. A set timeout function does not execute after exactly 1 second. It can be faster or slower depending on the amount of work that the browser is doing. A high-resolution timer uses performance.now to get a more accurate date object, which is accurate to about 1 millisecond. We combine this with a request animation frame, which can fire a callback about 60 times per second. We can use this timer as a stopwatch that can handle play and pause and seeking of our video. This timer is our master time and defines the playback time of our whole video at any given point. On our canvas, each element listens to this timer and shows and hides itself at the right time. So when a video layer becomes visible, it also has to start playing itself and pause itself when hiding. With Tella, it's also possible to trim, split, and reorganize your video segments. We do not cut these videos in the backend every time you make a small change, but use seeking to play back the part that you actually want to see. When you make a split in a video, we now have 2 video elements with their own part of the original video that we display. I will show you how this looks with an example. So here in this example, you can see how we play multiple video elements when you, for example, split a video into multiple parts. So on the left side, you can see a resulting video that will be on the screen for the viewers. And on the right side, you will see how we actually do this. So if you have 4 parts of a video, we have 4 different video elements, which we show and hide at the exact right time. And we also preload these video elements 5 seconds beforehand, so they are ready when they need to start. This approach gives us real-time collaboration and also means we can make video something more dynamic. We can add buttons anywhere in the video and even support things like tweets, live design files, or Google spreadsheets. This way it becomes more dynamic, like a web page. However, it also comes with a lot of challenges, mostly browser related. Because we fully rely on the browser to orchestrate our videos, things can go wrong sometimes. The video element was never really made for scheduling playback at a specific time. It seems to have been invented more for things like a YouTube or a video on a blog where you just place one video on a page and call it a day. We, however, are putting it to the test by loading a lot of video instances on a web page and loading, playing, and seeking through all of them. When you call play on a video with a HLS stream, on some devices and for some videos, it can take up to 500 milliseconds before it actually starts playing. And this probably happens because the browser has to start decoding, rendering, and doing more stuff that I don't know all the specifics of. On a YouTube, that would not be such a big deal since the user just has to wait a bit longer before they see the video. However, for us, it means that the video will be out of sync with the rest of the videos that also needed to start at the same time. Another interesting thing about the video elements is that they have their own clock. A video of 5 seconds might not play back in exactly 5 seconds if you compare it to the clock on your wall. Videos can drift, which means they can go faster or slower while playing, and by doing that, get out of sync with our master time. There's research being done that could potentially solve these problems by introducing a timing object in the browser. This timing object would be like the master time that I spoke about earlier, but it would also be linked to all video elements directly. The The browser then has to figure out when it should start playing the video, so it's exactly in sync with the timing object and not let it drift away from that time. The, the Web Audio API has a way to schedule audio that will be played at an exact time, and we hope that the same thing will happen for video eventually. But what if browsers never implement this? Is there still a way to get real-time editing working without an export step? We have one alternative idea that we're thinking about, which actually does not use multiple video elements at all, but still uses one. It would be really amazing if we could combine multiple videos into one in the backend in real time and then play them back into one video element in the client. We would tell the API how to position these videos and when to start and stop the parts, and it would then transcode them into one video on a just-in-time basis. That way, users can rearrange videos in real time, and we prevent playback issues. Right now, we're still investigating all the options that would make this possible. And if you have any good ideas about this, we would love to talk. Please send us an email. Thanks for watching, and if you have any more questions, I would love to hear them in the live Q&A. Bye.